Ever had a paper cut? That sudden stinging sensation from something as harmless as a piece of paper? Or maybe you've scraped your knee while playing sports or just being a bit clumsy. Suddenly there's blood, a bright red signal that something's amiss, and your body jumps into action, almost without you even realizing it. Instantly, your body's emergency team responds. No sirens needed, no dispatch call required. It's an internal response, a pre-programmed sequence of events. The first move, vasoconstriction. It's the body's immediate attempt to control the damage. The blood vessel squeezes tight, right at the site of the injury. It's like pinching a leaky hose to reduce the water flow. This quick squeeze slows the bleeding, minimizing blood loss from the damaged area, buying time for the next responders, the clotting factors and immune cells, to arrive on the scene and begin the repair process. It's an automatic reflex, a crucial first step in healing and preventing further complications. Without it, you'd lose blood much faster, potentially leading to more serious problems. This tiny action is the unsung hero that starts the healing race, setting off a cascade of biological events. It's a survival mechanism perfected over millions of years of evolution, ensuring our ancestors could survive injuries in a harsh environment. Even the smallest cut, the most insignificant prick, triggers this complex and vital response. So next time your cut stops bleeding, seemingly on its own, remember, your body's first responder, the vasoconstriction process, is already on the job, working tirelessly to protect you. That first squeeze sets the stage for everything that follows: clotting, inflammation, and ultimately, tissue repair. Your body is a finely tuned machine, a marvel of biological engineering, and this is just the beginning of its incredible self-healing capabilities. Science in action, a complex and fascinating process unfolding right under your skin every single time you get a cut. After the vessel constricts, slowing the flow of blood, it's time for the platelets to step in. These tiny but mighty components are crucial for initiating the next phase of the healing process. Platelets are essentially tiny cell fragments in your blood, constantly circulating and ready to respond to any sign of damage. They're like miniature first responders, always on patrol within your circulatory system. When a vessel is damaged, whether it's a small nick or a more significant tear, it sends out a chemical SOS. This signal acts like a beacon, alerting the platelets to the precise location of the injury. Drawn by the chemical signal, platelets rush in, converging on the damaged area with remarkable speed and efficiency. It's a coordinated response, ensuring that the repair process begins without delay. Upon reaching the injury site, platelets undergo a transformation. They become sticky, adhering to the broken edges of the blood vessel like glue. This stickiness is essential for forming the initial plug. They pile up, one on top of another, creating a growing mass of platelets that begins to fill the gap in the damaged vessel wall. This accumulation is the foundation of the platelet plug. This growing mass of platelets eventually forms a soft, temporary platelet plug. It's a fragile structure, but it serves a critical purpose in stemming the flow of blood. Think of it as stuffing rags in a leaky bucket, a quick and immediate solution to stop the water from gushing out. It's an imperfect fix, but it buys the body time to implement a more permanent repair. Quick but not permanent. The platelet plug is just the first step in a more complex and comprehensive healing process. This plug, despite its temporary nature, effectively blocks most of the bleeding in a matter of minutes, preventing excessive blood loss and stabilizing the situation. It's a temporary fix, a provisional measure designed to provide immediate relief and prevent further damage. It's holding things together, providing structural support until stronger, more durable repairs can arrive and take over. Remarkably, platelets only activate at injury sites, responding precisely to the chemical signals emitted by damaged vessels. This targeted activation is crucial, preventing dangerous clots from forming in healthy vessels elsewhere in the body, where they could obstruct blood flow and cause serious complications. Their precision is key, ensuring that the clotting process is confined to the specific area where it's needed. This prevents the formation of unwanted clots where you don't need them, maintaining healthy blood flow throughout the rest of your circulatory system. The platelet plug, while temporary, is the essential foundation for a stronger, more permanent seal that will ultimately restore the integrity of the blood vessel. It's teamwork in action, a coordinated effort with platelets acting as the first volunteers, rushing to the scene to initiate the repair process. The body's sophisticated repair crew is just getting started, and the platelet plug is their initial foothold in the ongoing effort to heal the damaged vessel. Next up, making the patch permanent, solidifying the repair and ensuring the long-term health and functionality of the blood vessel. The platelet plug is in place, but it needs reinforcement. Enter the coagulation cascade, a chain reaction of clotting factors. Each factor activates the next, like dominoes falling. The finale? Fibrin. It starts as fibrinogen, floating in your blood. The cascade transforms it into sticky fibrin threads. These threads weave through the platelet plug, creating a tough mesh. The result? A stable blood clot, much stronger than the initial plug. This clot withstands blood flow and forms a protective scab. The scab keeps germs out and blood in, letting skin heal underneath. Once healed, the scab falls off, revealing new skin. From soft plug to strong net to shield, your body's repair is complete. That's the science of healing right before your eyes. Blood clots are a fundamental part of our body's defense system. They save lives, but only when they form in the right place and at the right time. When blood flows smoothly through our veins and arteries, it delivers vital oxygen and nutrients to every cell in our body. However, when a clot forms inside a vessel with no injury, it's trouble. This is when the body's natural repair mechanism turns against itself. Slow blood flow, often due to inactivity or certain medical conditions or vessel damage, perhaps from high blood pressure or inflammation, can trigger these dangerous clots. These clots can disrupt the delicate balance of our circulatory system. A clot that develops in a deep leg vein is called deep vein thrombosis, or DVT. It's a serious condition that requires immediate medical attention. If a piece breaks off from this clot, it can travel through the bloodstream to the lungs, causing a life-threatening pulmonary embolism. This blockage prevents oxygen from reaching the blood, leading to severe consequences. Clots that form in the heart arteries can cause heart attacks, depriving the heart muscle of oxygen, and leading to irreversible damage. While in the brain, these clots can cause strokes, cutting off blood supply to vital brain tissue, and resulting in long-term disability or even death. So, what's the difference between a helpful clot and a harmful one? Helpful clots are essential for stopping bleeding at wounds, preventing excessive blood loss and initiating the healing process. Harmful clots, on the other hand, block blood flow inside vessels, obstructing the delivery of oxygen and nutrients to vital organs. It's a delicate balance. Location and timing are everything. The body's ability to form clots is crucial for survival, but when this process goes awry, the consequences can be devastating. The same system that saves you from bleeding to death can also put you at risk of life-threatening blockages. Understanding this intricate process helps us appreciate both the brilliance and the potential danger of clotting. Blood clotting, hero or villain, depending entirely on where it strikes and when it occurs. It's all about location, location, location. That's why your body's balance, maintaining healthy blood flow, and preventing vessel damage matters so much. To prevent dangerous clots, doctors use anticoagulants, blood thinners. They don't actually thin blood, but slow the clotting process by blocking clotting factors. Heparin works fast, often used in emergencies. Warfarin is a pill for long-term prevention, interfering with vitamin K. These medicines help people at high risk, like those with irregular heartbeats or past clots. But there's a trade-off: slower clotting means higher risk of bleeding. Doctors carefully balance the dose to prevent clots without causing too much bleeding. It's medical science stepping in when the body's system needs help. Anticoagulants save lives by keeping blood flowing safely. It's a careful balancing act, science and nature working together. What if your body can't clot well enough? That's hemophilia, a rare genetic disorder. People with hemophilia lack a key clotting factor, so the cascade stalls. Platelet plugs form, but without fibrin, clots are weak and unstable. Even small injuries can cause prolonged bleeding, and internal bleeding is a serious risk. Hemophilia is inherited, mostly affecting boys. Modern treatment replacement therapy, injecting the missing clotting factor. This lets people with hemophilia live active lives. It's a reminder of how vital every piece of the clotting puzzle is. When one part is missing, the whole system struggles. Medicine fills the gap, restoring balance. Blood clotting is a marvel, a system balancing bleeding and clotting every second. Too little clotting, like in hemophilia, and even small injuries are dangerous. Too much, and you risk heart attacks or strokes. Your body's checks and balances keep you safe, forming clots only when and where needed. It's a biological tightrope walk, happening without you noticing. Evolution has crafted this system to protect you. Next time you heal from a cut, remember the teamwork beneath your skin. Platelets, clotting factors, and fibrin, each plays a part. Your body is a dynamic, intelligent system, always working to protect you. The science of a simple blood clot reveals the wonder of biology.